There's a few different kinds of applications that we do in this course. You would have done some of them in grade 11. So this is one type. This is a tides type, right? So as the tide goes in and goes out, the water depth, water levels change. Okay, that's what this one is. Ferris wheel questions are another kind. Sunset questions are another kind. They can be a little bit tricky, but so there's a few different kinds, and any kind of pattern that makes a sinusoidal graph, so that looks like a sine curve or a cosine curve, could be an application. Okay, but we're just going to look at a few different types, and what we're doing today, we're going to use some technology to solve some of this. So that's not something you would have to do on the test. Okay, and I'll tell you sort of what you might have to do and what you might not have to do. Okay, so I think you want to kind of pay attention to that to be ready for it, I guess. So the tide off the coast of Durban, South Africa ranges from just under a foot at 9:45 to 6.4 feet at 3:45 and repeats this cycle every 12 hours. This is interesting. Remember what we did yesterday, and we talked about the max. So this is giving us the max and the min. There's the min and there's the max, and they are 6 hours apart, but the period length is 12 hours. We talked about that yesterday. The max and the min, the distance, the horizontal distance between them, so which is time in this case, is half the length of the period, right? So that fits, so that makes sense. Determine an equation. We're going to determine an equation in Sketch. We can kind of do those two probably at the same time. So let's go ahead and get started on those two things. A, I'm going to leave a little bit of space, and then B. So when it says Sketch, this is not a graph. It doesn't have to be on grid paper. In fact, a huge part of the reason why we learn how to graph is so that you can make a useful sketch quickly. So accurate graphing, and it's something you are tested on, so you do need to be able to do it, but it's not the most important thing that we get from graphing. Okay, we get a sense of the function so that we can sketch, so that we can do things like figure out where different points are on the graph, use our understanding of the function to answer the questions that we have to, right? That's the idea. So a sketch like this is really what we want to be able to do. And it says sketch, oh no, it just says sketch the relation. I'm going to do 2 cycles. Often it says to sketch kind of 2 cycles, so let's do 2 cycles. Okay, so at 9:45, I'm going to call this 0, so that's like midnight. So somewhere over here at 9:45, we have a minimum. And see how I'm going to plot that point, and I'm going to label it 0.8 feet. So we're not doing a scale, but we're going to label the points we have. We're going to label important points. And then 6 hours later, if this is about 6 hours, that's about 12 hours. There's another 6 hours. There's another 12 hours. So I can kind of fit a bunch in there. So at 6 hours later, we're at the max, which is 6.4 feet. And then we're at the min, and then we're at the max, and then we're back at the min. And these points are 9:45. So you could, in this case, again, since it's a sketch, I'm not going to worry too much about this. You could label this as 9:45 or 9.75, because the 9:45 a.m. is kind of meaningful. Like that's what we're measuring. Hours in the day is probably what we want to know, right? But 9.75 would be the numerical value on a proper scale. Oh, sorry, I meant to put it at the min. Yes. Because I was missing that tick mark, that's why. So then the next one is 3:45 p.m. And then it'll be 9:45 p.m. And then it'll be 3:45 a.m. And then it'll be back to 9:45 a.m. So what would this be? 345 on a proper scale. Does anybody know what that would be? Nice, 15.75. So we're talking like a 24-hour clock here, right? 7475. And then 9 is, anybody know that one? 21, very good. And then we're going to count, we're just adding 6 every time, so that would be the shortcut. So then I would go to 27.75, and then 33.75, and that would be, I suppose, number of hours after times 0 if you were using that scale. I think the kinds of questions we're going to get in this example are more about times of day anyway. And then it continues. And what would happen here? It would hit another max and come down, whoops, come down like this. And somewhere here it's going to cross that axis. I don't really know where that point is, so I'm not going to worry too much about that. So it asked us to come up with the equation. We sketched it first. And yesterday we noticed that sketching can help us come up with the equation. So even if you weren't asked to sketch, it might be a good idea. Okay. So somebody, let's get started. Help me out with the equation. What do we have to do to figure out the equation of this relation? Mm-hmm.
You can start off by writing it what you're looking for, so like A, K, C, and D.
Okay, so that's a good way to focus our thinking. Very good, thank you. So ultimately, we're trying to find A, K, C, and D. Pick one and see if you can figure out what it is. Who wants to help? How'd you get that? Nice. So I believe it was 6.4 minus 0.8 divided by 2. And you got 2.8? Great. What's next? Emma?
You can get through 0 lines value by taking, I did it with the min, and you can just take the middle and add the 2.
Okay, nice. So equals 0.8 plus 2.8. And what did that give you? 3.6. Awesome. What else? K shouldn't be too hard. What's K? How do you find K?
Just K up first.
Why would it be that? Okay. How can we figure out if that's right? Why are there only 2 people who are answering all the questions? What's that little formula that you use to find K? Emma?
You do 2 pi divided by the period, and essentially tells you the period at the top because it says it repeats.
Yeah, okay, good. So you have to understand, this is part of an application like this, is in the question, it will tell you, now it didn't have to tell us that the period, that it repeats every 12 hours, because it gave us the max and the min. So we could deduce the period from that, but in this case, it gave us that. The cycle repeats every 12 hours, there's your period length. But somewhere in the application, it'll give you enough information to figure out what the period length is. So that might be something that some people have a hard time with, wrapping their head around that. So that's what you should be thinking about as you practice today. One of the things. So this is 2 pi divided by 12. So you said 1/3 before. Be careful. And I said this last week or something, that all of the k values we've seen up till now were like a third or 3 or 2 or a half. But when you do applications, they often end up being in terms of pi. So you were on the right track. 6 was wrong, but the 2 over 12 would actually be 1 over 6 or pi over 6, right? So we want to have that pi in there in applications. You want to start expecting that, okay? And I think one of the easiest ways to do it is with that little formula, k, and the pi's don't cancel out anymore. What's the last thing that we're going to do here? Yes? C. Do you have any idea? Can you tell me anything about it? Okay, good. So we're going to do a shift to the right. Do we have to do a shift to the right? I'd say you wouldn't have to, because you can change the phase shift and get the same function in periodic functions, but I think that's a good idea to do it that way. So let's do it that way. Somebody tell me something else about it. There's a lot of little details that you have to think about that go into this. Go for it. Very nice. In other words, cos or sine, which one do you want to go with? There's no right or wrong answer here, but often I would say if the question talks about the max and the min and gives you those values, use cos. If the question, there's a few questions that talk about the middle between the max and the min for reasons that you'll see when they pop up, if they pop up. And if it gives you that, then I would talk about sine. Like, it's that easy. Okay, I wouldn't complicate it. And this one seems to me to lend itself to cosine. So we'll go with cosine. And you still have something to think about here. What do we, yep. Will it be flipped or not? And that depends on, again, where you choose to start. So I could either start here at the point it actually gives me, and my shift will be 9.75, not 945, right? Or I could start here, and we know what that point is. It's 3.75, and not be shifted. Okay? And I would say in a case like this, either is fine. You have to be able to understand yours. Like, you got to know which one you came up with. So let's start with the point that we were given. So I'm going to go back and flip this. A is going to be negative 2. Whoops, that's going to go away. Negative 2.8. And we did cos. And our C value is going to be 9.75. Okay, so depth at time t, usually for applications in grade 12, we start using function notation. We don't say y equals. Okay, we use meaningful variables. So depth at time t is equal to a negative 2.8 cos pi over 6 bracket t minus 9.75 plus 3.6. How's that? Everybody okay with that? Okay, I'm going to open up my graphing software. And I'm going to think about how I'm going to use my graphing software. So, well, first of all, I'm going to show about 24 hours or so. In fact, I can type this in. Let's see what happens. So remind me, because I can't see it, negative 2.8 cos bracket pi divided by 6 bracket again. X, I have to use X in the program. It's T, but I'm going to use X in the program. X minus 9.75 bracket bracket plus 3.6. Is that right? 6. Does that look right? Maximum looks like about 6 and a bit. Minimum is just under 1. Where do these maximums occur? So I can put a point on this and kind of drag it up. Oops, I'm going to turn something off here. Right? So I can drag it up so it looks like it's at, the max is at about 3.75. The min is at about 9.75. Like it looks to me, just when I typed in the equation, looks good to me. It's going up to the max again just after 15, after 21, and then back, what's that, 27, 33. So we look pretty good to me. How does that feel? So this is where some of these questions you can't really, you can, but we're doing them with technology today. That's not the kind of thing that I'll ask you to do on the test. Okay, use a graph to determine the time span in which the coast is surfable, so the depth is over 4.5. So here's what I'm going to do. I'm going to make a line, y equals 4.5 on my graph. And so there's the line, okay? So that it's surfable over that line. You could be required in some cases to, there are some kinds of graphs that you could do this with like on your own, not with technology. So you should have an understanding of like how you would find where it's above 4.5 on a graph. Does that make sense? Or maybe I would even give you, like I could give you an electronically graphed version of it and you would interpret the answers that way or something. That's something that's possible. Okay, so here are the points at about 1.3 or 1.4. So that's just before 1:30 in the morning. It becomes surfable. And then just after 6, that's not 13 minutes, right? That's like 6 and 10 minutes or something. It is no longer surfable. And then again at, so 1 o'clock, 1:20, and then it goes back down at 6 something, it's no longer surfable. Does that make sense? See how we used our graph to answer those? Okay, so let's just write that down. C. The beach is surfable between, and I could use the graph to get exact answers, like I could go a little bit further, but for this I'm just going to say between just after 1 a.m. to, let me just check this, to about just after 6 a.m. And 1 p.m. to 6 p.m. as well. I don't know if you know about surfing, but a lot of times surfers surf in the morning because the tide's higher then. So 1 p.m. to 6 p.m. as well. Stop me if you have any questions. D, use a graph to determine when the coast is swimmable. The depth is under 3 feet. So we'll do the same thing. And I go y equals 3, but now we're looking for where it's below that. So let me hide some of this stuff so it's kind of out of our way. And so like just after midnight it's swimmable, but we're not worried too much about that one. This point is 7.1, so just after 7 a.m. it's below the tide where it's safe to swim to just after 12, to about 12:20. Okay, so the beach is swimmable from just after 7 to about 12:20. And then that would repeat in the evening as well. Question E, how many times a day is the depth exactly 6 feet? This is something you should be able to answer without, like with your sketch, without technology. Okay, our understanding should be good enough for that. So here's what I'm going to do. I'm going to find where the day ends. So it's somewhere between 12:45 and 3:45. So between there, it's going to be at 6 feet 1, 2, 3, 4 times. Does that make sense? The water depth will be exactly 6 feet 4 times each day. So this is where, like, you could have all kinds of questions. What is the latest time that the depth is 2 feet? This one's a little bit trickier because on my sketch, I wouldn't know exactly where that occurs, but it's good enough that you could probably guess. But anyway, let's do this. Y equals 2, and I'm going to do this. X equals 24. So I can see where the day ends, and sure enough, there's one just before the day ends. That's exactly 2. 23.59. So what is that, like 1137 or something like that? I don't know. 2 feet. F. The latest time the depth is 2 feet is about 11, I'll just say 35 p.m. Everybody okay so far? Now here's a question you absolutely can answer without a graph, without technology. We'd use our calculator. But question G, which says, what is the depth at noon? How am I going to figure that out? Layla? Sub 12 in for T into our formula. So D at 12 equals negative 2.8 cos of pi over 6 bracket 12 minus 9.75 bracket plus 3.6, if my memory is correct. I want you to try this on your calculator, okay? Because that is a lot to punch in, and everybody's calculator is different. So you want to try this on your calculator. Anybody have an answer? I'm going to show you something. Okay, so just watch for a minute. Negative 2.8 cos, tell me if I type anything wrong. Cos, so it opened a bracket for me. Pi divided by 6 bracket 12 minus 9.75. I need two brackets closed plus 3.6. And I get 0.875. So what is that giving me? That's giving me a depth. And I am going to go, did anybody else get 0.875? Did you get something else? Some people got it 0.875. Some people got, you got something else? Okay, hold on. So let's go and check our, I love this. Let's check our graph. Where is 12 noon? It's around halfway between those two. 0.875 is just over our minimum. When I look at my graph, it looks like my answer is wrong. Don't you agree? What did you get?
I got
2.528. That looks reasonable to me. Do you think I punched it in correctly on my calculator? Did it look like I made a mistake? It did look like I made a mistake? What's my mistake? Pi over 6 and pi divided by 6 is the same thing. Do you have the same calculator I did? I do. And you use the fraction button.
Yeah.
So why did it make a difference? Pi over 6 and pi divided by 6 is the same thing. That's not what it is.
This is calculator would then multiply the 6 to the bracket with like the 12 and 9.7.
Yeah, so this is my little lesson that some calculators, not all of them, do this weird thing where when you divide by something and you put the bracket beside it, it keeps that in your denominator. So if I just add a times symbol there, did it overwrite something? Oh, I did it in the wrong spot. If I put a times symbol here, I get the right answer. Because then it doesn't do it. So it's like a BEDMAS thing. It's like your calculator and you miscommunicating on BEDMAS rules. Does that make sense? Kind of interesting. If it doesn't make sense, ask me about it again later. Interesting idea. So about 2.5. And our question was, what is the depth? So this equals approximately 2.5. Therefore, the depth is about 2.5 feet at noon. Any questions? Couple of lessons there. One, every once in a while, that thing about that little trick about the calculator, like, you know, if it's a new question, you forget that it's doing that and you get the wrong answer and you might not know it. So use your sketch to make sense of your answer. Always think, does my answer make sense? Always, 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 somehow, if you can, it's a really good idea to think, does your answer make sense? Because your calculator can do weird things. Maybe you put a typo in there. Maybe some people like wrote an 8 and then it looks like a 5 and so they put the wrong number in the calculator. Like, who knows, right? All kinds of things happen. It's always good to think about your answers. Be careful if you don't understand what it is your calculator's doing.